Hello my dear students, welcome to my Myedumarket math tutorial class. Today in this very video I'm going to teach you how to solve the system of equation using the concept of determinant of a matrix. So let's begin. A system of linear equations can be solved using the concept of determinant of a matrix as we learn how to solve system of equations, that is simultaneous equation using elimination, substitution, and even graphical methods. So this is another method also that we can adopt to solve those system of equations. And using concept of determinant to solve system of equation is known as Cramer's rule. So what we are learning virtually in this very lesson is this Cramer's rule. Let's see what it is. So the Cramer's rule. Suppose we have this system of equation, the general system of equations. That is, you have the very first equation, a1x plus b1y equals to c1, and you have the another pair, that is another similar equations, a2x plus b2y equals to c2. So you have two equations related. They have unknowns x and y. Those a1, b1, a2, b2 are the coefficients of those unknowns. So this is a general linear equation. If you have this, what Cramer's rule says we now do, if you have this, you want to solve them for x and y. Remember, solving this system of equation meaning finding the value of x and y that will fit both into these two equations, not only one equation. So let's move. So the matrix of this coefficient, what we now do first is to form a matrix using the coefficients of these unknowns and the constant term as well. So in the very first equation, I have the coefficient a1, b1 and the constant term c1. And in the second equation, I have the coefficient a2, b2 and the constant term c2. So I'm going to use those to form a 2 by 3 matrix like this. Look at it. A1, B1 and C1 are the coefficients and the constant term in the very first equation. Look at it here. While A2, B2, that is the row, second row elements I have over here. Now the coefficients I have in the second equation. So this is what you do first, but you have to take note of those equations. You have to rearrange them so that the constant term is by the right hand side, other terms in x and in y are in the left hand side. You have to do that before you form this matrix. So when you do that, Cramer says the solution to this very system of equation is given by this formula. The x value meaning the value of x would now be equals to determinant x divided by this determinant, that is del x over delta, and this del x is simply determinant of a particular matrix which we shall see, and this delta is also a determinant of another matrix which we shall see, all those matrices. And the value of y also will now be given by this formula, del y divided by delta, that is del. This also is determinant of a particular matrix which we shall see just now, and this delta is also determinant of a particular matrix which is the same as here. We are going to see all this. So this is what will give you the value of x and the value of y. Remember, the solution here we are trying to get is those values of x and y that will fit into both these two equations. So let us see what is del x, del y, and this delta. So what we simply do to get del x, look at it. This is del x, that is determinant of this matrix. These are the entries. But how I obtained these entries, let's go back to this very matrix. You now see, look at it, the last column which contains the constant terms of my original two equations, C1, C2. These are the entries I have in the last column. And A1, A2 are the coefficients of x in the two given equations. Look at them, A1, A2 are the coefficient of x, which I formed this matrix. So what will happen now? This column, C1, C2, that is the third column, will now replace the first column. So when that third column replaces the first column, A1 will now go, A2 will also go, and it will be replaced by C1 and C2. This is the matrix you obtained. So determinant of this very matrix will now be delta x. Let's see delta y. Delta y, look at it. It will be determinant of this very matrix, and how I obtained this very matrix also is similar to this. So that last column, which contains the constant term, will now replaces the second column, which contains the coefficients of the unknown y in the two equations. The coefficient of y is b1, coefficient of y in the second equation is b2, which I used to form this matrix, and they will now be representing columns, second column entries. So those column entries will now be, second column entries will now be replaced by C1 and C2, and you now have another matrix A1, C1, A2, C2. This is how I will get delta y. So determinant of that matrix is what we refer to as delta y here. But for the delta, what you simply do, the delta is that last column, which contains the constant term. The constant term C1 and C2, just cancel that last column. What remains, the four entries A1, B1, A2, B2 would now be, determinant of that would now be your delta. So this is how we arrived at delta x, delta y, and the delta is very easy. So when you now substitute them after getting all the determinants, you now substitute in the simple formula for value of x, delta x divided by delta, it will give you the value of x, delta y also divided by delta, it will give you the value of y. We are going to take examples and see how we can put this in practice. So let's move. Example number 1, it says solve the system of equation, that is solve simultaneous equations. These are the simultaneous equation given 7x minus 3y equals to 23, and the second equation minus 2x minus 3y equals to 5. So let's solve them simultaneously using this Cramer's rule. So solution to this, what we do first is to form a matrix using the coefficients of this unknowns and the constant term. So I'm going to form that matrix. This is the matrix, look at it. The coefficient here is 7, the coefficient here minus 3, the constant term 23, and the next is coefficient is minus 2, coefficient of y is minus 3 here, and the constant term is 5. Take note, before you form this matrix, you have to rearrange the equations in case the constant term is not by the right hand side. You have to have the constant term only by the right hand side, other terms by the left, before you form this matrix. In this case, we don't have to do that because already constant terms are by the right hand side. So next is to get your delta x. Your delta x, remember what we did. That column containing the constant term will now replace the terms that have that representing the coefficient of x. I'm getting delta x, so coefficient of x will now be deleted, and they will now be replaced by the constant that. So that column constant term will now replace this. So delta x is now going to be determinant of this matrix, 23 minus 3, then 5 minus 3, look at it. This 23 now replaced 7, 5 replaced minus 2. So let me continue. So determinant of this, product diagonal down minus product diagonal up, 23 times minus 3, that will be minus 69. And 5 times minus 3 is minus 15, but I'm subtracting product up, so that minus minus will change to plus 15. So I have minus 69 plus 15, that will give me answer minus 54. So determinant of this matrix, which is now delta x, is now minus 54. So let me move and get delta y. This is delta y. Delta y is now determinant of a particular matrix. Let's see what we do. That column containing the constant term will now replace the column containing the coefficients of y there. Look at it. So I'm going to have minus 3 replaced by 23 and 5. So I'm going to have a matrix like this. 7, 23, minus 2 and 5. Look at it here. Look at it. I'm deleting the second column, and that second column now, third column will now replace it. So I'm going to have this matrix. So determinant of this, let's find it. So product diagonal down minus product diagonal up. So 7 times 5 is 35. Minus 2 times minus 23 is minus 46, but I'm subtracting diagonal up, so that minus change to plus. So I'm going to have plus 46. So 35 plus 46, the result is going to be 81. So delta y is now going to be 81. So next is to get a delta. To get a delta, that is a determinant of just this matrix I obtained after deleting the column containing the constant term. So I'm going to have this entries remain. So determinant of that very matrix is now going to be 7 minus 3 and minus 2 minus 3. Look at it. So determinant of this, let me find it. Product diagonal down, 7 times minus 3 is minus 21, and product diagonal up is minus 2 times minus 3, which is positive 6. So subtract that 6. I'm going to have minus 21 minus 6. And this gives answer minus 27. So now I can now write the formula for finding the value of x and write the formula for finding the value of y. And that formula for value of x says x is the same thing as delta x over delta. I have my delta x, which is determinant of this, which I obtained as minus 54. So I'm going to substitute it here. And my delta, look at it here, is minus 27. So I'm going to substitute that. So I'm going to have minus 54 divided by minus 27. So I'm dividing this 54 by 27. Minus divided by minus is plus. 27 is 54. That is going to be 2. So the value of x is now 2. Let me move and get the value of y. So y would now be given by the formula delta y over delta. I have del y as 81. Look at it here. And I have my delta as minus 27. So let me substitute. I'm going to have 81 divided by minus 27. Plus divided by minus is minus, so 27 in 81 is going to be 3. So I'm going to have minus 3 here. So which means the solution to this system of equations is now x equals to 2 and y equals to minus 3. These are the values that will fit into both equation 1 and equation 2. So this is the Cramer's rule. With this, we have come to the end of this very lesson. I hope with just this one example, you'll be able to solve system of equations using determinant method. So thank you for listening.